Welcome to Koh Young here at IPC Apex Expo. Delighted to be joined by Joel Scutchfield. Good to see you again, Joel.
You as well, Trevor.
Okay.
I always enjoy meeting like this. We're making it a habit.
Making it happen, yeah, absolutely. So obviously the first question out my mouth is usually what's new?
You and everybody else that comes to the show, and as it should be. And as we discussed a few weeks ago when we talked briefly, we do have new. We have a lot of new. And it's basically in the functionality of the tools that you've seen from us in the past, in the way of enhancements, either through the GUI, like in the case of the Neptune system, where things like orange peel, bubble, connection anomalies or adhesion anomalies with regards to the materials, edge definition, those types of things, as well as programming enhancements, copy exact, et cetera, et cetera. The use of AI has been something that we've really focused on over the last year, and we're seeing here at the show the results of that in, again, all of those new features and the advanced intuitiveness. For example, the KAP tool, Koh Young Auto Programming, that we're showing is now heavily driven by the engines that we've created to achieve a much higher match rate on the initial data collection for the programming tool proper, which basically gives us much more coverage, and we will continue to advance that for the various attributes that need to be covered. But certainly things like body find, part dimension, all of the basic has been improved significantly.
So basically, you've got a library, which is a starting point for when you sell a new machine.
Correct.
They have access to a library of components and devices, which contains a whole suite of information.
All the usual suspects from a package dimension.
Right. But that becomes the basis then of their AI journey, as it were.
That's the starting point. Exactly. And the idea is, so with any programming system, the real goal here is to build that customer's library as quickly as possible. That's their library. It's based on their part numbers, their package types, which are package types are common, part numbers are not, right? But we want to build their library as quickly as we can. So what the auto programming tool is designed to do is just that, right? We want to basically create a scenario where the auto program tool is rendered not needed, which means we have basically developed robust library content for all of the various inspection attributes that we're looking for, all the fillet height, all the dimensional, all the presence, absence, character recognition, everything, bridge detection, all of that in the library. So that's basically what we're using the KAP tool for, and the AI piece to that is at this point on that package identification initiative. Okay. So if for instance there's something missing, we run the scan, 95% of the components are covered, 5% still are not, right? So instead of manually creating these, now we're doing that automatically through the use of collecting the data on those parts at various locations. So for instance, if you've got a 10-time user in 10 different locations of the single part number, but for whatever reason a couple of those were non-populated, then that comes back as basically missing data, right? But if that's the only point you're looking at, then you have no reference point. It's basically a fail. But if I can average the content of that particular part number on the board, I can still create a model even though there's a part missing in that particular location.
Right, you have to label it basically so
exactly.
that it's identifiable. So all of this then feeds into your overall Ksmart system.
It does.
Which is where you're then developing your AI model, eventually towards an agentive style AI system.
That's the goal. Yeah, that's the goal. And we can take Smart Review, for instance, which we're showing in the back of the booth here, which is basically designed, again, based on creation of AI engines to more properly, to assist the operator at this point in more properly determining defect classification, good, bad, what is it, et cetera, et cetera. And through the effort of measuring and basically taking the tolerance information, being able to at some point, adjust those tolerances, again, through the use of AI to better assist in, is that a real failure or a false failure? And to the point where now I can, once determined completely, we've reduced the false failures, now the agentic piece would be to send that information, those new tolerances, back into the inspection program itself,
right.
Adjust the tolerances in the inspection program, so we're not calling that a failure. Or
right,
and this
and
is
presumably
all based on the customer's assessment of what's good and bad.
Yeah,
right?
so
Within
the customer can
tolerance
say,
level.
look, I'm going to do this to IPC level 1 or level 2 or level 3.
Right.
And it'll make the adjustment whether it allows a 50% offset or whether it allows a 25% offset.
But you would be surprised, Trevor. I mean, if it were that easy. But this is the part where if there's people, something's going to go wrong.
Right.
That sounds bad, but okay, 50%. It's 51. It's okay. It's 52. It's okay. It's 53. It's okay. Well, then why don't you widen your tolerance, or the other direction, right? 49. It's okay.
Yeah.
Or the opposite way. Oh, it's no good. So we've got this mismatch in, and
you got to be working with the same set of data and the same tolerances.
Correct.
Every time. Yeah.
Ideally, yeah.
Yeah.
That's
And a machine's not going to accept 51 or 52. It's going to, if it's programmed to do 50.
It's absolute.
It's absolute.
It's absolute. Yeah. So the idea is to allow the customer to build in their process variation within acceptable levels, and we still want to basically, of course, ensure that what's going out the door is of high quality and solid and doesn't present any risk in terms of a field failure. So that's the ultimate piece. But at the same time, do that in a way that, again, minimizes the need for operator intervention to get to that point. So
I think all the work you're doing here on the AI and the libraries and that sort of thing, and the way that you're also interfacing with other vendors to be able to make your systems really compatible, all helps. It really does.
It continues to move forward, and as we've talked about previously, how do we completely get there, right?
Yeah.
We're still moving down that path, just like AI is growing in use and involvement in everything we do and many others for that matter.
It's going to be a journey.
That piece to it is also evolving. So again, as you know, we've partnered with the usual suspects for KPO mounter, for the auto feedback and full control now of speed, pressure release as anomalies are detected that can be corrected by those adjustments. And similarly on the mounter side for feeder, spindle, nozzle, and even XY positional theta on the fly.
Yeah.
But ideally, as we've talked about in the past, everybody needs to be able to work with everybody to really make this work. And that's where I believe the CFX part comes into play. We need to continue to evolve the events that we're reporting,
I agree.
so we can get beyond that. Because technically we can use what's there to create some type of auto feedback environment, but is it truly enough to cover everything that needs to be covered at this point? I think, and that's where these partnerships kind of allow us a little bit more flexibility there, right?
Absolutely.
But we still do that in line with what we see from CFX is let's make sure we cover these bases, and then ideally we can provide more input to the standards committee for what else needs to be included.
Needs to be done.
So at some point, it's just the module, right? And then It works with X, Y, Z, A, B, C.
Yeah. No, I mean, CFX development is working towards integrating better with digital twin, for example.
Yeah.
But I mean, all that data that it's going to need to be able to build out that model is going to come from you guys.
It is, and that's where it's. I've said this for years, Trevor. It's my standard line, and we agree. I think very much that the data is really important in all of this, and it's not just. When we say data, again, it's one of those topics that, much like smart factory and AI for that matter, that has what is the definition in the eye of the beholder, but the reality is that very robust, very accurate data set, very complete data set with significant amounts of data that we're gathering and that any one supplier can gather is what's going to drive the success of everything else down the line. And that's what we're seeing today with the AI, because again, it's not just a bag of data, it's very specific data. If I'm creating an engine to do something very specific, maybe that's to identify part markings. Mm-hmm. I need specific part marking data for that component, and I need a lot of it. So again, it's evolutionary. We start with the various attributes that are most obvious, and then we continue to add engines for those that are needed to complete the entire process.
Absolutely. So. I agree. So I wanted to ask you one other thing just before we finish, and that was that you've been moving in recent years deeper and deeper into the back-end packaging world. You've exhibited the last couple of years at Semicon West. I've noticed you'll be there again this year. I also believe, or a little bird tells me, that there's something in the works that you might be able to bring out at that show.
I think I can probably do that. So yes, we are quickly moving in that direction, and I will even share that I'm even a bit surprised how fast we've been able to turn the direction on that, and it's really speaks to the to our view and our confidence level in this industry being something that is worth pursuing, obviously, and when you take a look at the the size of what we feel that industry is going to be, it's equal to or greater than the total of AOI and SPI. So recently, actually prior to the Semicon West show last year, where we talked about the ZenStar, we introduced basically a clean room version, a fan out wafer level wafer handling version of the Meister, which again allows us to basically inspect balls and bumps in that 50 micron diameter, 20 micron height range on the wafer level surface in a class 10 clean room with the FOUPs, with the EFEM, with all the needed handling mechanisms for that particular world. The next step is to increase the ability, add the additional horsepower to take that
to the next level
diameter and bump dimension lower, right? That world operates in a very different space, and the next iteration, which we're today calling the Zeta machine, will be something that's going to use a little bit different technology, which we will supplement with our Moray to get into that micro bump, below 30 micron, and just continue driving down on the both the diameter, the spacing, and the height. So we hope to have a system of some kind potentially at the Semicon West show in October, but we are very quickly moving in that direction, and it's very exciting. I mean, we recently, I think we discussed not long ago, the fact that we recently aligned with a sales channel rep organization here in the U.S. that specializes in that world, which is very different. And
you need the people with the relationships.
You need the relationship. You need the talking, the terminology, and the time, right? The focus to address that. It's certainly different enough from what we're doing here today that we know is going to open doors, and has already. They're bringing us already applications here in the U.S. So there's things going on already, and there's a lot more to come. Obviously, we're going to be attending various conferences and so on and so forth leading up to the Semicon West show, and I think it's been very well received to know that this investment does have a certain payoff at the end, based on the fact that these needs are real, and these needs are real in the U.S. today, and they will continue to grow as we go forward.
Yeah, no, I agree, and we're really excited to see it when it comes. And
you'll be the first. I'll make sure.
I will absolutely make sure I'm at the front of the queue, the front of the line. But it's great to see you always evolving, and all the work that you're doing on AI behind the scenes. I think it's incredibly important. So
it's the way forward.
Yeah,
I think we're gonna. Now AI is the new buzzword at these shows and throughout the industry.
It's going to be Agentive AI shortly.
Yeah,
that's the next one.
It's going to continue to evolve. So, we're going to continue to push the envelope. You know that.
Right. Yeah. We'll look forward to it. We'll follow your.
We have the data set to be able to do it.
Good.
And not everybody does. So let's make hay, as I like to say.
Great to hear that.
Boy, saying.
Yeah. Okay. Well, thank you very much for the update, Joel.
Very welcome.
It's always good to hear, and we'll see you. Well, if not beforehand, we'll see you at Semicon West.
Absolutely. I look forward to that.
Okay. Thanks very much.